Simplifying radicals with variables. Okay, so let me give you an example of what I mean. So let's say we have the square root of x to the 18th power. Okay, we do want to utilize the rule that was introduced in section 8.3, which says any base with a fraction exponent is equivalent to a radical. And the index of that radical is in the denominator of that fraction. So if we're looking at a square root, we know that index is going to be 2. Right? So that's what we have here. The index here is an invisible 2. So what I'm going to do is take that variable, x to the 18th power, right? That's going to be my a. Whatever is inside of my radical is my a. And I'm going to write this to the 1/2 power. The reason I'm using a 1/2 power is because of this rule here, that any radical can be written as a fraction with an exponent. So we have 1/2, which represents our square root. I can then use my exponent property where these guys multiply. Right? So 18 times 1/2 is 9. Okay? X to the 9th power is going to be my solution. Now, with section 8.1, we need to be a little cautious because, as you saw from the previous question on question 2, square roots in particular, anything with an even root, really, square roots, 4th roots, 6th roots, anything that has an even root always will have a positive result. Okay? So if I tell you that that variable x is equal to some negative number, and that negative number is raised to an odd power, the answer from that negative number to the odd power, that answer is going to be negative. We don't want that answer to ever be negative because it came from a square root. The answers that come from square root should always be positive. So because this answer has potential to be negative, and again, it has potential to be negative because of the odd power, okay? I have to put absolute values around that variable. Okay? Let me give you a different or a second example to kind of maybe help clear this up. Let's put a number in here this time. So we'll have another square root. Let's do 144 x to the 26th power. Okay. So the square root of 144, if you know your square roots, we know that that answer is 12. If we don't know our square roots, that's okay. We can type in our calculator 144 to the 1/2 power, and the calculator will do for you the square root, and it should come out to be 12. All right. Now, as for the variable, that variable x to the 26th will also be to the 1/2 power. Right? The 1/2 power represents a square root. I'm using that rule up here again. So 1/2 times 26, I'm using the multiplication of exponents rule. That's going to turn into x to the 13th power. Because 1/2 of 26 is 13. Now, again, this is a square root. Square roots only produce positive answers. That variable, because of the odd power, that variable has potential to be negative. If I tell you that that variable is -1, any negative number to an odd power will result in a negative answer. So because we have a square root, my answer should always be positive. I need to make sure that that variable is always going to be positive. So I'm going to put absolute values around that variable. Let me give you a different example of something when we don't need absolute values. Okay. Something like, let's maybe do something like this. Let's do 36 x to the 6th power, and I'll give you an extra variable, y to the 20th. So square root of 36, if we don't know our square roots, you can put in the calculator 36, and then on your calculator, you can do 1/2 as your exponent. That should give you the answer of 6. And square root of 36 is 6. Actually, let me change this to a power of 8. Hopefully you wrote in pencil and can erase that real quick. I apologize for that. All right, so x to the 8th needs to be to the 1/2 power. That represents the square root, right? And then y to the 20th also needs to be to the 1/2 power. So all those 1/2 powers represent square roots. I can use my exponent property of multiplication. This becomes x to the 4th, right? Half of 8 is 4. And this becomes y to the 10th, right? Half of 20 is 10. Now, I do not need absolute values on this question because anything to the 4th power, any number, positive or negative, any number to the 4th power will always result in a positive result. The same can be said for y to the 10th. Any negative number or positive number to the 10th power will always result in a positive. So I don't need to put absolute values around any of my variables here, right? Only when the variable has potential to be negative, like this example up here, only when the variable has potential to be negative, and you'll know it has potential to be negative because it's an odd power. That's when you're going to use your absolute values. If the variable has no potential to be negative, leave it alone. Okay. Last example I want to give you is something different than a square root. We've done 3 square root examples already. Let's do a cube root. Okay, so the index is 3. So I'm going to give you a number, and then we'll throw some variables in here. Let's do that. Okay. So because we don't have a square root, we have a cube root, we're going to do 125 to the power of 1/3. Cube root is 1/3 power, square root is 1/2 power. This one will be x to the 9th, and then 1/3 for the cube root, and then y to the 6th to the 1/3 power. Okay. Your calculator will do this for you. Now, if you know your cube roots, you don't need to punch that in the calculator. If you know your cube root, this is going to be 5. Okay. 5 times 5 times 5 is 125. Okay. Now, using the property of multiplication, that's going to be x cubed. Okay. 1/3 times 9 is 3. And then this will be y squared. 1/3 times 6, that's where we got the 2. Now, I do not need absolute values on this question at all. You may be thinking, why not put an absolute value around the x cubed? Because any odd power has the potential to be negative. Well, I don't need absolute values because of where it came from. It came from a cube root. You are allowed to have negative results from a cube root, right? Because you can get a negative number by doing -5 times -5 times -5, for example. You'll get a negative number. So cube roots or odd roots, negatives, that's fair game. You're allowed negatives from an odd root. That's why I'm not using any absolute values on this question. In contrast, when you have an even root, such as a square root, a 4th root, a 6th root, you are not allowed to have negatives. And that is why we are looking to use absolute values when you have an even root. We use absolute values to make sure our answer is always positive. If you've got questions, please reach out. But that is the end of our quick little lesson. Take care, guys. Bye.